everybody. Let's talk about solving systems of equations, but now we're going to talk about some special cases. So at this point, you should know how to solve systems by graphing, by substitution, by elimination. Now we're going to look at some special cases, special instances that happen along the way when you're solving these. So what you know right now is every system you solve gets one solution. What that means is when you graph it, you have one line, you have another, and where they crisscross is the solution. So we find those coordinates x and y, and that is our solution. So where they crisscross happens is the solution. Algebraically, what that looks like is you're able to solve and figure out x, you're able to plug in, solve, and figure out y. You're able to solve those equations for x and y. That's what you know right now. What you're going to learn is there's two other cases we have to worry about. We could have systems that have no solution and systems that have infinite solutions. So let's think about what that looks like graphically. So where we crisscross, that and where that intersection is, that's one solution. So if I have no solution, that should mean I have no intersection, no crisscrossing. So graphically, what that looks like is you have two parallel lines. Two lines that never intersect each other, so we can never find an xy coordinate. Now what happens when you're solving these problems by substitution and elimination? All your variables disappear. X is gone, y is gone, and you're just left with numbers. And what you might run into is you might run into cases where you end up with like 0 is equal to 7. Well, that doesn't make sense because 0 is never equal to 7. Or you might get like 2 is equal to 8. Well, 2 and 8 are not equal. Those are different numbers. You're left with just two numbers that aren't equal to each other. It doesn't make sense. It doesn't mean you did the problem wrong. It means you have a no solution problem. So you just write no solution, you can move on. Our final case we have to look at is infinite solutions. So one solution is intersecting once. An infinite solution would mean we're intersecting an infinite amount of times. So what that looks like is you have a line, and then when you graph your second line in the system, it's going to fall right on top of the first line so that everywhere it intersects, well, it intersects here, 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 here. It intersects an infinite amount of times. So what that looks like when you're solving by substitution or elimination is all your x's and all your y's go away. You have no variables left. And you're instead left with statements like 0 is equal to 0. Well, is 0 ever equal to 0? Yes, all the time. You might get like 2 is equal to 2. Is 2 equal to 2? Yes, all the time. When you get a case like this where it's the same number, that means infinite solutions. Okay, so I'm going to show you two problems that we work out so that we can see what does it look like when you get no solution and infinite solution. So my first problem, I have y equals 3x plus 2 and 6x minus 2y equals 8. So this is a case where we have the y is all by itself and nothing else. So this kind of leads me to believe we should probably do substitution here. So what I'm going to do is I'm going to take, well, I know y is equal to 3x plus 2. So anytime I see y, I can plug in 3x plus 2. So in the second line of this equation, I'm going to replace my y's with 3x plus 2. So we're going to just plug in right here. So what this looks like is I have a 6x, I have a minus, I have a 2. Instead of y, I'm going to plug in 3x plus 2. And then we have equals 8. So that's substitution. All I need to do is solve for x here because all my y's are all gone, just left with x. So I need to distribute first. Take that negative 2, multiply it through my parentheses, so I still have the 6x. Negative 2 times 3x is negative 6x. Negative 2 times positive 2 is negative 4, and that is equal to 8. 6x minus 6x, those are gone, because 6x minus 6x would be 0. 0 times x is 0. So my x's are gone. I'm just left with negative 4 is equal to 8. I haven't made any mistake. Everything's done correctly mathematically. What this means is, well, is negative 4 equal to 8? No, they're never equal. So what I have here is a problem that has no solution. All right, let's look at one more problem here. So I have 2x minus 4y equals 8, 1x minus 2y equals 4. So I don't see y equals, I don't see an x equals or a y equals. This problem is set up for elimination. So I got to look to eliminate either my x's or my y's. So for my x's, I see a 2x and a 1x. I guess by multiplying, I could probably get these both to be 2's, make one positive and one negative. If I wanted to eliminate y, I see a negative 4y and a negative 2y. I guess I could probably make both of those 4 by multiplication, to make sure one's positive 4 and one's negative 4. It doesn't matter which one we choose. I'm going to go ahead and try and focus on my x's. So if the top is 2x, I would like to see negative 2x here instead. So I have to think, what should I multiply 1 by to get negative 2? Well, I'm going to multiply by negative 2. So here's what I'm going to do. I'm going to rewrite the top equation just right here. 2x minus 4y equals 8. And I'm going to distribute this negative 2 all the way through. Negative 2 times 1x is negative 2x. Negative 2 times negative 2y is positive 4y. And negative 2 times 4 is negative 8. So I got what I wanted, 2x, negative 2x. All I have to do is add straight down now. 2x minus 2x, that's 0x, that's eliminated. Negative 4y and positive 4y, the y's are eliminated. So all I'm left with is 0. On the right side of the equal sign, I have 8 minus 8, which is also 0. So when you get 0 equals 0, this does not mean you did it wrong. This is totally fine. When is 0 equal to 0? Always. So what this means is infinite solutions. So again, a quick review. Whenever your x's and y's, all your variables go away, if you have two numbers that are not equal, it's no solution. When you have two numbers that are equal, it's infinite solution. If your x or y stays around, that means you could solve it for x or y, so go ahead and do that as well. And that was solving systems of equations, special cases.